What is up, you guys? It's Max here again, and in this video, I'm going to show you how we can solve longest common prefix, which is a LeetCode problem. So, reading the problem description, it says they want us to rate a function that will return the longest common prefix amongst an array of strings. So if we take a look at a couple of their examples, we have this array of strings, flower, flow, and flight, and the longest common prefix would be FL in this case, because if we take a look, FLO, but I is kind of the outlier here, so that would leave us with FL. Then we have this example where there's no common prefix at all, so we would return an empty string. And I'm going to kind of break this down into two parts, where I'm going to whiteboard in MS Paint, and then I'm going to jump into my text editor and debug through the example that we went over in the whiteboarding. So to hop in, I'm kind of going to show an example similar to this first one. So if we had an array of strings of the following: flower, flow, and flowing, we basically, well, before we even get into that, we want to kind of discuss a couple edge cases. If we're ever given an array that's just of size 0, we would just want to return an empty string because there are no strings in this array. Also, if we were given an array of size 1, we would just return the first element of this array, and because it itself would be the longest common prefix because there's no other elements in that array. So we would just return example. So those are two edge cases. And to get started into how we would go forward with programming this, we could basically compare the first word to everything else in the array. So we would basically set up this first word, and we kind of iterate over every single letter in the first word, and then we would have some pointer that would help us out, and kind of once we check each one, we would increment it, so it would kind of follow along as we're looping over these other letters. So to get started, essentially what you do is you would say, hey, is this F equal to F? Why, yes it is. So let's check the next element in the array. So we check, is this F equal to F? Yes it is. So we would go ahead, and that's the last element of the strings array. So we'd go ahead and add F to our longest common prefix because they all match. And then we would go ahead and we would go to the next character in our first element of our strings array. And not only that, well, first we would add the F, and then we would increment the pointer that we're using to iterate over the rest of the array, pretty much. L. So we compare, hey, is L equal to L? Yes it is. Is L equal to L? Definitely. All right, we will then, since we're at the end of the strings array, we are going to add this L to our longest common prefix. Not only that, we're going to then increment this pointer guy to 0, 1, 2. So when we come in and analyze again, it'll be set up at this O. So then we go to the next letter in our starting word. And since we already incremented this pointer to 2, we're going to start here. Say, is O equal to O? Yes it is. Is O equal to O? Yes. All right, add that puppy to our longest common prefix. I know this is going like downwards, but you get the gist. So we then increment that puppy, so once we go to the next letter, it's already initialized at the W. Oh, that's not what I wanted. I wanted to just move him. All right. So is W equal to W? Definitely. W equal to W? Definitely. Add the letter, increment our pointer, and so then we would start him off at the here. But there's no this doesn't exist when we go to check this element in this string right here. There's actually not an E, so we would just immediately just return, because if it goes out of bounds, we just want to check hey, is the index we're at iterating over our starting word greater than the index, the length of, I guess, length minus 1 of, let's see, of this this string in the array. So we would then break and we would return the longest common prefix here. All right, so that makes sense. We're going to hop into my text editor and kind of debug through and kind of show you how it's set up. I have the exact same example. I set a breakpoint and we're going to get right into it. So let's start debugging. We call this function and we pass in these strings in this array. We check the couple edge cases we had talked about, and it doesn't trip any of those. We initialize the longest to that empty string so we can keep appending to it. Set up our comparison word, which is flower. We're going to be comparing it to everything else in the array, and we set compare index. Now, why do we have this? Well, kind of what I mentioned earlier. This guy is kind of going to be following along as we iterate over the first word. So we're going to need that comparison index to keep us in check. And I'll show you what I mean. So here, we're going to loop over each character in flower, and we're going to compare it to the other word from 1 onwards. And why is it 1 onwards? Well, we're already here. We already have our comparison word. We just want to go over everything else pretty much. So we start I at 1 right here, and we make sure that it doesn't go out of bounds. So less than the length and I++. So we set the current letter of the word we're comparing it to. So this F in flow is equal to strings I, so 1, and then comparison index is 0. See, that's what's going to help us keep us in check. So it's going to let us iterate over each letter of the following elements. So we then check, hey, just make sure it's not out of bounds. Is the comparison index greater than strings I length? So like that was that edge case, like when that E wasn't even here, we would then break and return our longest common prefix. And then we check, hey, is it actually, are they equal to each other? And they are, so we don't return the longest common prefix yet. We're going to keep going. Next, we're going to check the next, so we can see that let's see, I is 2 now. So we're looking at flowing, and we're comparing the F and the F between flower and flowing. We say, hey, and so we set up the letter. We say, hey, are you guys the same, or are you out of bounds? Nope, we're good. So then we've reached the end of that, or all the elements, and we would then increment the comparison index and do longest plus equals comparison letter. We add that F checked out for everything. And so now when we go to compare, we're going to be comparing the L's, right? So we're in this loop, so comparison letter is now L, and then we start comparing again this element and then this element. So you kind of get the gist here. I'm going to go through this. We check the L's for both of them. They all check out. We increment the comparison index, and we append that onto our longest common prefix. We do the same for O. Boom. Add that puppy. As you can see, longest common prefix is now FLO. It's probably just going to check out for the W. We append that to our longest common prefix. Now here is where it's going to break, because we are now comparison index is 4. We incremented this enough times that we're now checking where this E is in the first. We're at the E of here. We're checking E across these other elements. So when we go here, the comparison index is 4, and that's greater than the length of this element here. And so then we would just return longest common prefix, and we console log it. And if we go to our terminal, well, I guess it didn't log it in my debugger, but prefix2.js, it would output flow. And that's pretty much the icing on the cake. We got what we were looking for. So now, most satisfying part, let's plug this bad boy into our LeetCode. And we will paste this here. We're going to check if it passes the just quick example. And yes it does. We submit. And judging. And accepted. Good stuff. We did it. I hope you enjoyed, and I hope to catch you in the next video. Feel free to shoot me a follow on Twitter or GitHub. I'm pretty active on those. I'll probably shoot you a follow back. I love tweeting about code and business and whatnot. So yeah, I hope to see you guys in the next video, and hope you have a nice rest of your day. All right, peace.